Imagine standing under a starry sky, somewhere in the vastness of the Pacific, in 1958. Near the islands of the British Empire, the US was about to launch an experiment that merged the dawn of the space age with the shadow of nuclear brinkmanship. Welcome to Project Argus, a series of high-altitude nuclear tests that sought to understand how nuclear explosions affect our Earth's magnetosphere and ionosphere. Why would anyone want to detonate nukes in space? Well, back in those days, the US wanted to solve the conundrum of high-altitude nuclear detonations and their impact on radio wave propagation and satellite stability. This was a matter of national security during an era where information was power and space was quickly becoming the next military frontier. The tests spanned a short, intense period from August 27th to September 6, 1958. Picture this. Argus 1 detonated on August 27th at an altitude of 300 kilometers, about the height where the ISS orbits today. Argus 10 followed 3 days later, tweaking the altitude and configuration to gather varied data. Finally, Argus 3 wrapped it up on September 6th. Each explosion sent shockwaves through the atmosphere and radiation belts, creating artificial belts eerily reminiscent of the natural Van Allen belts. These artificial Argus belts caught the world's attention. Suddenly, nuclear detonations in space were not just theoretical, they were real and impactful. The data from these tests provided groundbreaking insights into how nuclear explosions interact with the Earth's magnetic field. Ever wonder why our modern satellites seem so hardy despite floating above a rather hostile environment? Part of the thanks goes to the findings from Argus tests. They fed into a wealth of knowledge that improved the design and resilience of our space technologies. But it's not just about the hard science. The Argus tests also added urgency to the global dialogue, leading to the Partial Nuclear Test Ban Treaty. This was one of the first steps towards limiting atmospheric nuclear testing and curbing the race for more destructive capabilities. These explosions in the sky were a striking reminder that advancing technology and safeguarding our planet often intertwines in complex ways. They left us with a legacy, a more profound understanding of space science, and pushed forward the necessity of responsible innovation. Argus showed us that even in times of intense rivalry and fear, scientific curiosity could drive initiatives that lead not just to better weaponry, but to better wisdom. So next time you think about the Cold War, remember that amidst the tension, there were also groundbreaking, sky-shattering experiments that led us to where we are today, standing tall in space exploration and communication technology.